Assalamualaikum warahmatullahi wabarakatuh. My name is Emfazianan with NPM 23312072. Today we're gonna talk about the topic of greedy algorithm for the traveling salesman problem, or TSP. The traveling salesman problem, or TSP, is a well-known challenge in mathematics and computer science. It asks how a salesman can travel to a list of cities, visit a city exactly once, and then return to the starting city, all while keeping the total travel distance as short as possible. This problem is important because it reflects real-world scenarios like planning delivery routes, scheduling transportation, or optimizing travel paths. However, TSP is a complex problem, and finding the absolute best solution takes a lot of time as the number of cities increases. For this reason, simple approaches like the greedy algorithm are often to find quick approximate solution. The greedy algorithm is one of the easiest ways to solve TSP. It works by making decisions step by step, choosing the best opinion available at each moment. Specifically, the algorithm always picks the closest visit city as the next stop by focusing on the source distance at every step. The algorithm tries to build a good solution. However, it is important to understand that the greedy algorithm does not always find the shortest possible route. Instead, it provides a solution that is good enough for many particular situations, especially when speed is more important than accuracy. The process of using the greedy algorithm starts by selecting a city as the starting point. This can be any city chosen randomly or based on some criteria like alphabetical order or this position on a map. Once the starting city is decided, the algorithm marks it as visit from there. The distance to all the visit cities are calculated, and the closest city is chosen as the next destination. The salesman travels to that city, mark it as visit, and repeat the same process by always choosing the nearest visit city. The algorithm will route step by step. This process continues until all the cities have been visited. After reaching the final city, the algorithm requires the salesman to return to the starting city to complete the journey. This final leg ensures that the route from a complete loop as required by the TSP to calculate the total distance. The algorithm adds up all the distance traveled between each pair of cities, including the last trip back to the starting city. While the final route might not always be the shortest possible one, it is typically efficient and easy to compute. The greedy algorithm has several advantages that make it useful for the solving TSP. First, it is very simple and easy to understand. The step-by-step process of choosing the nearest city makes it straightforward to implement. Second, it is computationally fast, which means it can handle problem with a moderate number of cities in a short amount of time. These qualities make it ideal for real-world application where an approximate solution is sufficient, such as optimizing delivery route for a small number of locations or planning simple travel it nearest. Despite its simplicity, the greedy algorithm has some significant limitation. One major drawback is that it focuses only on local decision, meaning it chooses the new city at each step without considering how this choice might affect the overall road. This approach can lead to suboptimal solutions, especially in cases where the cities are uniformly distributed or where choosing a slightly feather city early on could result in a much shorter total road. Additionally, the solution depends on the choice of the starting city. Different starting points can produce different roads, and some may be much longer than others. In a conclusion, the greedy algorithm is a practical method to solving the traveling salesman problem when simplicity and speed are more important than finding the perfect solution. It is best suited for small or medium-sized problems or for situations where an approximate answer is good enough. However, for larger problems or cases where precision is critical, more advanced methods like dynamic programming, branch and bound, or motorized approach such as genetic algorithms and colony optimization should be used. These techniques are designed to handle the complexity of TSP for effectively ensuring more accurate and optimal solution. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.